Hey, welcome back to Algebra 2. Today's lesson 4.6, the method of common bases. This is basically a brand new concept for us, and we are going to avoid using our calculator. We should be able to do this pretty much using just our brains. I know that's a scary thing, but we're going to take baby steps. This isn't that hard, and we're going to really evolve this when we get into Unit 5. All right, so exercise 1. Solve each of the following simple exponential equations by writing each side of the equation using a common base. So what I mean by that is consider the numbers 2 and 16 in letter A, and we're going to look for a number that they're both powers of. So if we think about the powers of 2, 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8, and so on and so forth, times 2, times 2, times 2. So these are all powers of 2. So we're going to rewrite 2 to the x, and we're going to rewrite 16 here as 2 to the fourth power, because 2 to the fourth power is 16. So when you have a common base, basically what you do at this point now is just set your exponents equal to each other, so x has to equal 4. That's what we mean by a common base. So keeping that in mind, taking a look at letter B, we have 3 to the x, and hopefully you're realizing that 27 is also a power of 3. So I'm going to rewrite this as 3 to the third power, because 3 times 3 is 9, times 3 is 27. So in this case, simply x is going to equal 3. We're going to look, it's this x is equal to this 3. A little trickier with C. I know there's a fraction in there, which I've always said I can make grown men cry giving them fractions. So we're just going to rewrite this. Hopefully you notice that 25 is going to be a power of 2. And because it's in the denominator, it's going to be the same thing as, so this is the same thing as 1 over 5 squared, which is equal to 5 to the negative 2. And again, if you need to take it off to the side and spend a little time manipulating it, you can absolutely do that. So on this one, x is equal to negative 2. And our last one are actually, they're both factors, they're both powers of 2, but they're also both powers of 4. So start with the larger one. So I'm going to rewrite 16 as 4 squared to the x power is equal to 4 to the first. I put the 1 in there so I'm not confused as to what my exponent is. So I get 4 to the 2x is equal to 4 to the first, because I multiply those. So I get 2x is equal to 1. Make sure you solve it. And x is equal to a half. And that makes sense, right? Because 16 to the 1/2 power is the same thing as the square root of 16. And we know the square root of 16 is 4. All right, so moving on. We're going to take a look down here at exercise 2. We're going to get a little bit more complicated, but here, all we're doing here is simplifying. We're not even solving this, because I want to take a little baby step backwards before I start solving problems like this. So this simply says to simplify it. No pun intended. Simply says to simplify. So when you have anything raised to a power, you keep your base and you multiply your powers together. So this is the same thing as 2 to the 3x. B is the same thing as 3 to the 8x. C is 5 to the negative 1 times 3x minus 7, which is the same thing as 5 to the negative 3x plus 7. Or you can rewrite it as 5 to the 7 minus 3x. Either one of those would be perfectly fine. This one is 4 to the negative 3 times 1 minus x squared, which is 4 to the negative 3 plus 3x squared. Or we can rewrite this as 4 to the 3x squared minus 3. Either one of those would be acceptable. All right, so write down what you need to. All we did was simplify. Don't overthink this. This is not that hard. All right, let's go on to exercise 3. So now we're solving, and we're going to be getting a little bit more complicated here. So in exercise 3, I'm just going to rewrite this as powers. So 8 and 32, if we go back to what we looked at before, hold on, I have them written right here. See this? I have an 8 here, and I have a 32 here. So these are both bases. These are both powers of 2. So I'm going to rewrite 8 as 2 to the 3rd power to the x equals, and I'm going to rewrite 32 as 2 to the 5th power. You can use your calculator to determine these. So now that you have the same base, you have 3x is equal to 5. You set those exponents equal. Divide both sides by 3, and x is equal to 5 over 3. Moving on to B. 9 and 27, hopefully you're recognizing they're both powers of 3. So this is going to be 3 squared, because that's our 9. I'm rewriting that. I put it in parentheses to keep myself organized, is equal to 3 to the 3rd power, right? 3 times 3 is 9, times 3 is 27. And now I have the same base, so I'm going to set my exponents equal to each other. 2x plus 1 is equal to 3. 4x plus 2 is equal to 3. Minus 2, I get 4x is equal to 1. Divide both sides by 4, and x is equal to 1/4. Remember, at any time you need to pause or rewind and look at it again, maybe sometimes it's easier to watch it than pause and write it down. So if we're looking at C, that might be a really good thing to do right here, because this one looks a little bit more complicated than the others. So we're going to look at 125 and 1 over 25, and I'm hoping you recognize that these are both powers of 5. So 125 is the same thing as 5 to the 3rd power. 5 to the 2nd power is 25, and 25 times 5 is 125. So I got to keep that x on the outside. Now, this 1 over 25 here, this is the same thing as 5 to the negative 2. So let's rewrite that as 5 to the negative 2 times 4 minus x. And at this point now, we are going to multiply our exponents together here and set them equal. So 3x is equal to negative 2, negative 8 plus 2x. Even the best of us make mistakes, so make sure you're doing them right. So I get x is equal to negative 8. Now, there's also a way that you can check this using your calculator, right? You can go into your calculator, you can store negative 8 to x and put that in, see if it turns out to be true, or you can simply substitute it in. In exercise 4, which of the following represents the solution to the equation right here? Now, like I said, I told you this before, that sometimes when you write things down, it makes it a little friendlier. So when you take a look at this, you get 2 to the x squared minus 3 is equal to 64. So sometimes when you write them down, just taking the minute to write it down kind of lets you analyze it in your brain a little bit. So let's try to get this in common bases. So 64 is a power of 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So I can rewrite this as 2 to the 6th power, 2 to the x squared minus 3. At this point now, we're going to set them equal to each other. And beware how you do this. I'm going to bring it over to this side if it's okay. I have x cubed minus 3 is equal to 6. So there's 2 schools of thoughts on this. The first school of thought is we can separate this and think about it like, I'm sorry, this is x squared. All right, So you have x squared minus 3 is equal to 6. Add 3 to both sides. I get x squared is equal to 9, and x is equal to 3. And so you thought. So beware here, because 3 is not the only value that x squared gives you 9, because x can also equal negative 3, because negative 3 times negative 3 is positive 9. Now, I'm going to remind you that when we have, this is where those concepts come in Algebra 2. When you have an x squared function, it's a quadratic. So you can be asking yourself, how many roots are there? How many zeros are there to a quadratic? And the answer is 2. So you should be looking for 2 answers. They're not always real answers, and we'll get into that a little bit later in the course. But you should always be looking for 2 answers. The other way that you can approach this is by using a quadratic. We know when we solve a quadratic, we set it equal to 0. So x squared minus 9 is equal to 0. These are my favorite in the whole world to factor, because the difference of perfect squares. So when you solve this, you get x is equal to negative 3 and x is equal to positive 3. So using that way, at least we don't forget about that negative 3. And our answer is right here in number 1. You don't have to write both of these ways down. I want you to write down the way that appeals to you the most. So when you're done with that, I'll meet you at exercise 5. Okay, so at what x coordinate will the graph of y equals this mess intersect the graph of, okay, let me bring this down just a little bit so we can see this. I want this one, thank you. Y equals this one. Now it says what x coordinate. So you're looking at an intersection point, but because we have this a sitting over here, it's basically a way that tells you you can't use your calculator. So if you recall, like I told you, write things down. We have y equals 25 x minus a, and I have y equals 1 over 125 to the 3x plus 1. So notice that they're both equal to y. We have y equals here, we have y equals here, which means I can take this one and set it equal to this one. And then from there, I think the rest of it will look a little bit easier. And then again, maybe not. So here we have a simple case of common basis. So 25 is the same thing as 5 squared. 1 over 25 is 5 to the negative 3. And then at this point now, we can do our common bases. This one and this one. So I'm going to go over to the left here, if that's okay. So I have 2x minus a is equal to negative 3x plus 1. And we're simply going to solve this for x. If you look at our answers, they're all x equals. So it kind of gives us a hint of what to do. So 2x minus 2a is equal to negative 9x minus 3. Distribute those. And we're solving for x, which means I would like to bring the 9x over to the left. So these cancel, and I get 11x minus 2a is equal to negative 3. And then I'm going to add the 2a to both sides. And remember, when I do that, they're not like terms. So 11x is equal to 2a minus 3, or negative 3 plus 2a. And then divide both sides by 11. And these cancel to 1. And x is equal to 2a minus 3 divided by 11. Okay, so that's the end of our lesson for today. Although I would like to take a look quickly just at independent practice E and F. You take a look at these get a little crazy looking. But again, you're working with common bases. So I'm going to help you out here just to give you a hint. These two have a common base of 6, and these two have a common base of 5. All right? And maybe I'll even help you out a little beyond that. 216 is the same thing as 6 to the 3rd power. 6 to the negative 4, 3x minus 2. And then you should be able to figure out f if I tell you that it has a base of 5. All right? And in number 2, when you look at the bottom, it says algebraically determine the intersection point. I'm going to remind you what an intersection point looks like, an x comma y. So once we find out what x is, you have to go back and find the y by plugging it into one of your original equations. Okay, so if you're going to do it now, great. It might be a good idea to spend a little bit of time and see if you can do some of them on your own. If not, if I give you instructions to do them in class, we'll do them together the next time we meet. All right? So until next time, make good choices and always be safe.